Alright, for logarithmic equations, there's a couple different ways you could solve these. So, if logs on all terms, if every term has a log, there's no, just plain numbers, no constants, then you can equate the logs, just set everything equal. Sometimes you'll have to go back to that expand to condense lesson and condense it first using the properties. If not everything has a log, so if you've got just some plain numbers, then what you're going to want to do is get all the logs together and change to exponential form. And finally, just kind of remember that you cannot take the log of a negative number. So we might get ones that just don't work. Now let's try our first one here. If you look at this first one, I've got a log on the left and I've got a log on the right. I don't have anything other than that. Those log base 5s will just cancel out. Because what we're trying to do is we're making everything equal, so all I need to know is the stuff after the logs has to be equal. So what does x have to be so that these are equal to each other? Alright, I'm going to subtract 2x from both sides so I don't have to mess with negatives. And then I'm going to add 9 to both sides so that I get 6 is equal to x. Again, if you want, you can plug that back in just to make sure that it works. Or just kind of look in your head. You know that 2 times 6 is 12. 12 minus 3 is 9, so that would be a 9 right there. 3 times 6 is 18. 18 minus 9 is 9. So you would get the exact same answers on both sides. Alright, take a look at the next one. If you look at this one, here's a natural log in front of this term, here's a natural log in front of this term, but this term is missing a natural log. So no natural log on that last term. We can't just throw one on there, so if you're thinking that, nice try. It doesn't work. So what I want to do is try to make there only be one natural log. Remember, the minus means to combine them together with a division. So I'm going to take whatever was first, x plus 4, and divide it by x minus 3. Now that I only have one natural log, you kind of have a choice here as to what to do. You could change it to exponential form. So what I would do there, you got to kind of remember that there is a base of e. So I would start with e to the third power is equal to x plus 4 over x minus 3. Or something else that you could do, let me get rid of that e here for a second. Another thing that you could do is you could say, well, I know that there's a natural log, so I could actually e both sides, or give both sides a base of e. And here's what it would look like. So essentially all I did is I gave both sides of the equation a base of e. Now, that looks nasty in my opinion, but if you look here on the left, that e ln base e just cancels out, and you have the exact same equation that I started with, just by changing it to exponential form. So that's why I call that a shortcut, because in my opinion, that's a little bit shorter to work with. But now I actually need to solve this, so I need a little bit more room, so hang on here. Alright, so I just rewrote it so I had a little bit more room. First thing I want to get rid of is a fraction, because that just looks so ugly. So what I'm going to do is I'm going to multiply both sides by the denominator, x minus 3. And that's going to make that all go away. I am going to need to distribute that e cubed, so now I have e cubed x minus e cubed times 3 equals x plus 4. Alright, I'm trying to get the x by itself. I know this looks really bad, so what I'm going to do here is I'm going to actually try to change, well, I'm going to combine as many like terms, but remember, e is just a number. It's just 2.7 approximately. So I'm going to subtract x and get all the x's on one side. So I've got that. I'm going to add 3e cubed to both sides, so I have all the numbers on both sides. So that's gone. So now what I actually have over on the left, I'm going to get my calculator and I'm going to type I'm going to type into my calculator e cubed minus 1. And it gives me 19.0855, and keeps going. So 19.0855, I'm just going to leave that number on my calculator, equals, remember this is all just a number over here too, so again, use your calculator to type that in. And that gives me 64.2566, 64. Alright, maybe you already caught on, but I did forget my x over on the left side, because when I typed e cubed minus 1, I still had to have that x there. So my goal now is to get x by itself, so what I need to do is I need to divide by that 19.0855 number. You should still have that 64 on your calculator, so just type divided by, and then, if you're careful with this, you can go back and just highlight that 19.08 and hit enter so you don't have to retype all of it, and you should get 3.367, we'll round to 3 decimal places. X is equal to 3.367. Now, I am saying to check for extraneous solutions. You can't have a negative number after log. If you were to type or plug 3.367 in here, 3.3 plus 4 is not going to be negative. We're good to go. And then if I plug it in here, 3.3 minus 3, I'm still okay. I don't have a negative number after log, so we're good. Let's try a couple more here. If you look at number 7, you should see right away that we do not have logs on both sides. I only have one log. So you've got two options. Your first option is to change it to exponential form. That's what I like to do. I think that's the shortcut. So if I change this to exponential form, I start with the base, which is a 4, cube it, because that was the number over there, and this is going to equal whatever was after the log, which happens to be 5x minus 1. Now, notice there are parentheses around that 5x minus 1. These are very, very important here. If the parentheses weren't there, it would be a totally different problem. You'd have to add the 1 first, and you'd get a different answer. Alright, I told you there were 2 different ways to do this before I go on. So what you could have done also is you could have just given both sides a base of 4. I picked a 4 because this base is 4, so all of this just disappears and I'm left with 5x minus 1 is equal to 4 cubed, which is the exact same thing I have from changing the log form to exponential form. From here you just need to solve. 4 cubed is 64. That equals 5x minus 1. Add the 1 to both sides, so 65 is equal to 5x. When you divide by 5, you get x is equal to 13. Make sure you check by plugging it back in. Log base 4 of 5 times 13 minus 1, so 5 times 13 minus 1 is positive. We are good. Alright. Next one. You might look at this and think, oh, there's a log on both sides, and it really does look like that. Log, log. But there is this one right here that does not have a log. So what I'm going to do is put my logarithms together and go from there. So what I'm going to do is I'm going to add the log from the right to the left. Alright, now I'm going to combine these two logs. Notice there's an addition sign. So the property says to make sure we multiply whatever is after the logs. So I've got log base 12 of x times x plus 1. And I only have one log now. Again, it's up to you if you want to use exponential form or if you're going to raise both sides to exponents, base both sides, I guess you would say, you would pick a 12 because there's a 12 here. I like exponential form, so I'm going to start with that base of 12, raise it to the first power, and that's equal to x times x plus 1. I'm going to distribute the x here, so I've got 12 to the first is 12 equals x squared plus x. I'm going to set this equal to 0. So I have x squared plus x minus 12 is equal to 0. Now we have a quadratic that we need to factor or use quadratic formula. Thankfully this one does factor into a plus 4 and a minus 3. So we're going to get two answers here. And my two answers are negative 4 and positive 3. Don't just stop there. Make sure you check. If I check the x equals negative 4 back into my original problem, if I plug that back into my original problem, I'm going to get rid of some of this so that I have room to work. If I plug that back into my original problem, I have log base 12 is equal to 1 minus log base 12 of negative 4 plus 1. Well, right away, negative 4 plus 1 is going to give me log base 12 of negative 3. You can try to type that in their calculator, but it does not work. You're going to get an error message, which tells me that x equals negative 4 is not a solution. Don't just assume that the other one is going to work. Make sure you plug it back in to check. So I've got log base 12 of x is 3, is equal to 1 minus log base 12 of 3 plus 1. I've got a positive log on the left, a positive log on the right. 3 plus 1 is 4, which means that x plus 3 will work. Now, I did miss plugging in my negative 4 right here when I was doing this. This should have said log base 12 of negative 4, which I could have stopped right there then because I have a negative log and that's no good. It just doesn't work. So my answer for number 8 is 3. No negative logs. Alright, next thing we're going to do are some word problems. So, if you need to stop and look back over some of these logs, the word problems are going to be setting up and then using logarithms to solve, or exponents.